Hey everyone, Miss Barber here again with another thrilling day in geometry land, learning about word problems related to finding side lengths in right triangles using trig functions. So to start, we are just going to review the video of 8.2. And yes, we are going a little bit out of order. We're doing 8.2, then 8.4. Don't worry, we're going to come back to 8.3 tomorrow. If what I'm talking about in these next 4 examples is confusing to you, pause this video and then find 8.2 and review the basics of finding sides using trig ratios. So remember, SOHCAHTOA is my friend. The sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. These 3 ratios definitions need to be memorized in your brain. To start, you find your reference angle. My reference angle is 72. Remember, you label your sides based off the reference angle. X is the hypotenuse, and 8 is opposite. Opposite and hypotenuse is going to be sine. So I can write the sine of 72 equals opposite 8 over x, which is the hypotenuse. When you've got x in your denominator, denominator means divide. So go ahead, switch sine 72 with the value of x. So x is now going to be 8 divided by sine 72. You can pop that bad boy in your calculator, and when you do, you're going to get x is 8.4, rounding to the nearest tenth, which is 1 decimal. Letter B, 15 is my reference angle. Opposite 90 is 50, that's my hypotenuse, so x has to be adjacent. Adjacent hypotenuse, that's cosine. So I'm going to say the cosine of 15 is x over 50, adjacent over hypotenuse. X is in the numerator this time. To undo dividing by 50, you multiply both sides by 50. So in your calculator, 50 times cosine 15, you're going to get x equals 48.3. Pause the video. You can try the next 2 on your own. I can tell you when you're done, you should be getting that x is 68.6 in letter C, and x is 17.4 in letter D. So go ahead, pause the video, try it on your own. Make sure you know what you're doing before you move on to the word problems. In order to complete these word problems, you're going to need to know these 2 definitions. The angle of elevation is when, if you look up at an object, the angle of your line of sight makes with the horizontal line. Somebody's trying to get a hold of me. We're going to ignore that phone call. So here is your angle of elevation down here. If I am looking, think of a ladybug, it's how much it has to look up in order to see something. Angle of depression, which is right here, is how much you would have to look down from your horizontal line to see something. Notice the orange angle and the blue angle here. They are alternate interior angles, back from chapter 3. We learned that given 2 parallel lines and horizontal lines will be parallel, alternate interior angles are going to be congruent. So it turns out that these 2 angles, the angle of elevation and the angle of depression, are going to be equal. So you can always label one and then use the other because you know they will be the same. Here are some word problems. The height of the Eiffel Tower is 1,050 feet. From the top, the angle of depression to a soccer ball on the ground is 20 degrees. Find to the nearest foot the distance of the soccer ball to the base of the Eiffel Tower. So here's going to be the Eiffel Tower, and we're going to label it 1050. From the top, so here's the top. Remember, angle of depression is from a horizontal line, so that's my dotted line here, to a soccer ball. This is going to be 20 degrees. So that's my angle of depression. To the nearest foot, we want to find the distance from the soccer ball to the base of the Eiffel Tower. So we're going to try to find this point here, or that side here. Now, here's the issue. This angle of depression is not inside my triangle at all. But as I said earlier, the angle of depression and the angle of elevation down here will be the same. So this will also be 20 degrees. That is in my triangle. So now I can use that opposite, adjacent, and hypotenuse to find the value of x. 20 is my reference angle, 1050 is opposite, x is adjacent. Well, opposite and adjacent will be tangent. So I'm going to say the tangent of 20 degrees equals opposite, which is 1050, over adjacent, which is x. X is in my denominator, so for a denominator you switch and divide. So x is going to be 1050 divided by tangent 20. We can put that in my calculator. Please make sure, if you haven't checked already, that your calculator is in degrees. 1050 divided by tangent 20. Rounding to the nearest foot, 2884.8 will round up to 2885. So x is going to be 2885 feet for the value of x. In letter B, a boy flying a kite with a string 150 feet long estimates the angle of elevation to the kite to be 45. So here's my string, and my kite's here at the top, and the string is 150 feet long. The angle of elevation, so from where the bottom of the string is to the top of the kite, is 45 degrees. So let's label this 45 degrees. Assuming the string is straight, how high is the kite? So we want to find this value here, the height of the kite. Well, 45 is my reference angle, so I'm going to label my sides based off of that. H is opposite. 150 will be the hypotenuse of this right triangle. Opposite and hypotenuse is sine. So I'm going to say the sine of 45 degrees equals h over 150. My x is in the numerator, 150 is in the denominator, so I'm going to multiply both sides by 150. 150 times sine 45, put that in your calculator, and you're going to get 106.1, and my units will be feet. Letter C, an airplane directly over Lakeview High School passes directly over Lakeview High School. A student at Lakeshore High School, which is 2.2 miles away, finds the angle of elevation to the plane to be 70. Find the altitude of the plane. Altitude and height are the same word. So we're going to have a plane over here, and it's right over LHS. That's LHS. And we want to find this height, or the altitude, but I'll call it H so we don't confuse A with adjacent. A student at Lakeshore, so there's some kid over here, it's all sad because he goes to Lakeshore. He's 2.2 miles away. This is turning out to be a fabulous photo. Finds the angle of elevation, so from where he's looking up, to be 70 degrees. So 70 there is in my triangle is my reference angle. H is opposite, and 2.2 is adjacent. I don't care about my hypotenuse, not labeled here. Well, opposite and adjacent is tangent. So I can say the tangent of 70 degrees equals H over 2.2. Multiply both sides by 2.2. Put that in your calculator. You're going to get H. The height is roughly about 6.0 miles. That's the altitude. It's flying about 6 miles above ground. And then finally, last word problem, letter D. How far from the vertical wall of a building is the base of a 30-foot ladder? Please remember, ladders are always the hypotenuse. They have to lean against something. Vertical is up and down, so how far from the vertical wall of a building is the base of a 30-foot ladder? So your ladder is 30, your hypotenuse here is 30. We want to know how far from the vertical wall. So we'll call this x. It has an angle of depression of 75. So remember, depression is from a horizontal line looking down, would be 75 degrees. 75 isn't in my triangle, but I know that the angle of elevation is and will be the same. So I can label that 75 as my reference angle. 30 is the hypotenuse, x is adjacent. Adjacent and hypotenuse is cosine. So I'm going to say the cosine of 75 equals adjacent, which is x, over hypotenuse, which is 30. And I'm going to multiply both sides by 30. We've done lots of these now. So multiplying both sides by 30, you're going to get x is about 7.8 feet. So about 7.8 feet away, the ladder needs to go from the ground. Last thing, special right triangles. Ooh, guess I gotta go home. Just kidding. All right, so special right triangles, let's try to finish it up before the next bell rings. We learned about these in chapter 5. So in 45, 45, 90, you may have used the variable x or a and said x root 2 or a root 2. But if we let x or a be 1, then it would be 1 root 2, which is just root 2. Same thing here, opposite 30, you may have called x or b, and then b root 3, and then 2b, or x root 3, 2x. If we let b or x be 1, then opposite 30 would be 1, opposite 60 would be root 3, and opposite 90 would be 2. We can actually find trig ratios based off of the angles. So let's look at just 30 first. So 30, using 30 as my reference angle, opposite would be 1, adjacent would be root 3, and hypotenuse would be 2. So we could label the sine, cosine, and tangent of 30 because the sine would be opposite over hypotenuse, which is 1 over 2. The cosine would be adjacent over hypotenuse, which would be root 3 over 2. And the tangent would be opposite over adjacent, which would be 1 over root 3. Remember, you can't leave root 3 in the denominator, so you'd have to multiply by root 3 over root 3. That's called rationalizing. So you could also rewrite it as root 3 over plain old 3. These two are the same answer. It's just written in a more correct form with root 3 over 3. So that's for 30 degrees. Let's go back up and do it for 45. It doesn't matter which 45 you choose. I'm going to choose this one down here. But you'll get the same answers if you choose the other one. Opposite 45 is 1. Adjacent would be 1. Hypotenuse would be root 2. So the sine of 45 would be opposite over hypotenuse, which is 1 over root 2. And again, the more correct form would be multiplying by root 2 over root 2 to get root 2 over 2. The cosine would be adjacent over hypotenuse, which is 1 over root 2, which is the same thing as the sine. So I'd multiply by root 2 over root 2 to get root 2 over 2 as a more simplified preferred form. Lastly is tangent, which is opposite over adjacent. Well, opposite is 1, adjacent's 1, so 1 over 1 will give you 1. So the tangent of a 45-degree angle is 1. Lastly is 60 degrees, so let's look at my 60 up here. Using 60 as my reference angle, the hypotenuse from 30 won't change. So that's still my hypotenuse, but now opposite and adjacent change because opposite 60 will be root 3 and adjacent will be 1. So my sine and cosine and tangent are going to vary slightly from my 30 because my opposite and adjacent changed. So now the sine of 60 is going to be root 3 opposite over hypotenuse, which is 2. The cosine is going to be adjacent over hypotenuse, which will be 1/2. And tangent will be opposite over adjacent, which is root 3 over 1, which we can rewrite just as root 3. So anytime you see a 30, 45, 30, 60, 90 or 45, 45, 90 triangle. You don't actually have to use trig or a calculator because we know, oh, I lied. I couldn't finish before the bell. Because we know what these ratios are. So you don't have to in 45, 45, 90 to use trig. You could use special right triangles instead, but most kids do prefer trig, so feel free to use that. But make sure you know how to find these ratios in 45, 45, 90 and 30, 60, 90 triangles. That's it for lesson 8.2, or 8.4, my apologies. I hope you all learned a lot.